Machu Picchu is the foundations for an effective drainage of rainwater that have made Machu Picchu survive for hundreds of years.
Machu Picchu was never supposed to impress tourists. It was supposed to defeat nature. For over a century, the terraces were described as simple farmland. In 2025, that story collapsed.
If we look at Machu Picchu, we see buildings on the surface. What we don't see is that 60% is underground. It's absolutely breathtaking.
Using ground-penetrating radar and 3D scanning, researchers discovered that Machu Picchu's terraces are not just platforms.
Look at that. There we go. Who's that? That could be one of them. Yeah, it looks like it's on a bit of a terrace.
They are a multi-layered drainage and seismic damping system that can absorb earthquakes and extreme rainfall better than many modern retaining walls.
Retention wall of a terrace. Now, inside these terraces, what we have will allow rainwater to infiltrate slowly, and it won't affect the structure.
And that discovery exposed a level of planning no one was prepared to explain. What lies beneath the terraces was never meant to be seen. For more than 100 years, Machu Picchu was presented as a peaceful royal retreat, a sacred ceremonial site, and a simple agricultural center. Official guides said the terraces existed mainly to grow corn, potatoes, and other Andean crops. Tourists were told they were standing on ancient farmland shaped by patient farmers using stone and soil. Almost no one questioned that explanation. In the 2025, that story collapsed completely when modern scanning technology showed that the terraces were never designed as farmland first. They were designed as a structural and hydraulic control system hidden inside a mountain. A multinational research team arrived with ground-penetrating radar, drone-based laser scanning, and three-dimensional reconstruction software. When the first scans appeared on the monitors, the team went silent. What they expected to see was compact soil behind stone walls. What they saw instead was a layered internal structure that looked engineered. The terraces were not solid earth. They were built like filters. Each terrace contains 4 deliberate layers. The bottom layer is made of large stones. Some weigh more than 1,000 pounds. These stones are arranged to distribute pressure and prevent wall collapse. Above them is a layer of carefully sorted gravel. The stones are almost identical in size. This allows water to pass through while blocking soil. Above that sits a sand layer that traps smaller particles. Above the sand sits topsoil where crops once grew. This structure is not decorative and it is not optional. It exists to stop the mountain from collapsing. Water is the main cause of landslides in steep terrain because it turns solid ground into unstable weight. When water builds up inside soil, it pushes outward with enormous force until stone walls crack and entire slopes fail. The layered system inside each terrace removes that threat before it can destroy anything. Water is trapped, filtered, and forced into controlled stone channels that drain it away from every weak point. Without this hidden system, the terraces would not have survived even a few decades. Machu Picchu would have been erased by gravity, rain, and pressure long before modern humans ever saw it. Laser scans then revealed something worse and far more disturbing. Beneath the terraces, carved directly into solid bedrock, runs a network of drainage channels. These channels connect the entire mountainside. Water does not escape randomly. It is guided through stone tunnels that follow precise angles. The channels merge and separate like veins inside a living body. Engineers on the team described the system as frighteningly modern. One researcher said the mountain looked less like a ruin and more like a buried machine. When the three-dimensional model was completed, the team could rotate the entire slope on a screen. Every terrace followed the same internal design. All 700 terraces were built to the same specifications. The team then asked a question that made the room uncomfortable. How did people without written engineering manuals, without surveying equipment, and without modern measuring tools build a system that looks like it was designed by trained civil engineers? Spanish records describe workers forced to carry stones up the mountain under strict punishment. Men collapsed from lack of oxygen, others died from exhaustion, but those same records never mention training, diagrams, or explanations. They describe suffering. They do not describe knowledge. The researchers then forced simulated stormwater into the three-dimensional model to test whether the hidden drainage system truly performed as the structure suggested it should. The water entered the top terrace under pressure levels that normally destroy retaining walls. Instead of building up, it vanished into the layers. It moved through the gravel, passed through the sand, and disappeared into the underground channels without resistance. No pools formed, no pressure developed, no water reached the stone faces. The system responded as if it had been built to expect failure and prevent it before it could begin. Engineers watching the test said the result was unsettling because the terraces behaved like a modern engineered drainage network, not like ancient stone farming steps. This discovery changed the identity of Machu Picchu. It was no longer just a city on a mountain. It was a mountain that had been rebuilt from the inside. Once the structure was exposed, the next question could no longer be avoided. If this hidden system was real, then its performance under real disasters would decide whether it was merely impressive or something far more disturbing. Why this system outperforms modern engineering. Modern retaining walls are designed with computers, reinforced concrete, steel anchors, and drainage pipes. Even with all that technology, engineers expect them to fail within 50 to 100 years. Cracks appear, water pressure builds, soil shifts, repairs become unavoidable. In many parts of the world, retaining walls collapse much sooner. In California, entire highway slopes have failed after heavy rains despite modern reinforcement. In Japan, engineered hillside walls have fractured during earthquakes even with advanced seismic design. Modern engineering does not promise permanence. It only promises delay. Machu Picchu's terraces have stood untouched for more than 600 years. And here is the shocking part. They stand in one of the wettest and most unstable mountain regions on Earth. The site receives heavy rainfall for much of the year. During peak storms, several inches of rain can fall in a single hour. In modern cities, that level of rainfall floods streets, destroys storm drains, and causes slope failures. Landslides in mountain regions regularly kill people and bury homes, even when modern drainage systems are present. At Machu Picchu, there is no runoff. There is no erosion. There are no collapsed walls. Kenneth Wright, past president of the American Society of Civil Engineers who studied the terraces for over 30 years, measured their drainage capacity and compared it to modern storm systems. He found that the terraces can absorb rainfall events that overwhelm modern drainage networks. He stated that he had never seen a better designed agricultural drainage system. He added that he had seen modern systems costing millions fail in a fraction of the time these terraces have stood. That alone is uncomfortable for modern engineering. But rainfall is not the greatest threat in the Andes. Earthquakes are. The region has experienced repeated powerful earthquakes for centuries. Spanish colonial records describe cities collapsing, populations dying beneath debris, and entire districts being erased. Cusco, the former capital of the Inca Empire, was repeatedly shattered by violent earthquakes that killed residents, buried homes, and left entire districts in ruins. Lima, the Spanish colonial capital of Peru, suffered even worse disasters. Massive earthquakes and tsunamis destroyed large portions of the city, crushed thousands of people beneath collapsing structures, and forced survivors to abandon whole neighborhoods. Fires followed the shaking. Disease followed the chaos. Each rebuilding only prepared the city for the next disaster. While human lives were lost and cities were erased, Machu Picchu remained standing above the destruction, untouched by structural collapse. A structural engineer from Peru's National University of Engineering tested the terrace system using seismic simulation software. Her team applied forces matching known historical earthquakes. These were not mild tests. They represented ground motion capable of destroying modern retaining walls. The terraces did not fracture. Instead, the stones shifted slightly and then returned to position. The tiny gaps between stones widened and closed during the simulations. This movement absorbed seismic energy instead of resisting it. Modern engineers call this seismic damping. Today, buildings achieve it using steel bearings, rubber isolators, and sliding foundations. Machu Picchu achieved it using only stone placement and gravity. The engineer stated that she had designed modern reinforced concrete buildings that did not perform as well under the same seismic forces. The shock does not end there. Engineers from Purdue University built a full digital model of Machu Picchu's drainage system using the 3D scan data. They then asked modern engineering software to redesign the system from scratch. The computer tested thousands of different drainage layouts, changing channel angles, depths, spacing, and flow paths to see if any modern configuration could move water more efficiently or more safely. None of the computer-generated designs performed better than the ancient one. Many allowed water to collect in dangerous areas. Others increased pressure behind terrace walls. Some caused erosion in places where Machu Picchu's system shows none. Dr. James Harrison from Purdue explained that modern engineers normally depend on repeated failure to improve a design. He said Machu Picchu's drainage network appears to have reached an optimal solution without leaving any visible evidence of trial, error, or correction. Wright later wrote that, based on modern engineering standards, the terrace system should have failed long ago. He stated that the terraces work so well only because they were built using deliberate, advanced understanding of water control, soil pressure, and structural stability. And that leads directly to the most dangerous question of all. How was this physically built with the tools that supposedly existed at the time? The tool and precision problem. When engineers measured the stonework at Machu Picchu with precision instruments, the numbers revealed construction tolerances that challenge assumptions about what ancient builders could achieve. This is the point where the normal explanation begins to break. The terraces are not just well built. They are built with a level of precision that modern builders struggle to repeat, even with electricity and advanced tools. In 2014, a research team used three-dimensional scanning on the terrace retaining walls. This type of scanning records the shape of every stone surface in extremely fine detail. It can measure gaps and alignment with millimeter accuracy. The team was not looking for beauty, they were looking for mistakes. They found almost none. The facing stones of many terrace walls fit together with tolerances of less than 2 millimeters. A tolerance is the amount of empty space allowed between surfaces that are supposed to meet. 2 millimeters is thinner than the backing of many paper notebooks. It is smaller than the thickness of 2 stacked coins in many currencies. When stones are cut this precisely, there is no way to hide mistakes. Builders normally use mortar to fill gaps between stones. Mortar is a paste made from lime, sand, or cement that seals uneven cuts. Machu Picchu does not use mortar. Its walls are built using dry stone construction, which means every stone must lock into place by shape alone. If a stone is cut incorrectly, the wall becomes unstable. There is no filler material to correct errors. The stone either fits perfectly or the structure fails. Modern stonemasons use diamond-tipped saws, grinders, and laser levels to achieve tight fits. Even with those tools, consistent 2 millimeter fitting across long walls is difficult. Stone has natural flaws. Cuts chip. Surfaces warp. That is why modern projects often accept larger gaps and then fill them with cement. At Machu Picchu, the stones were shaped to meet perfectly without filler. This creates a brutal question. How do you repeatedly cut and fit heavy stones precisely on a steep mountainside? Mainstream archaeology says the Inca had no iron tools and no steel. They had stone hammers and softer metal tools such as copper and bronze. They also used harder stones to pound and shape other stones. That method can work for rough shaping. It does not explain consistent precision on this scale. The problem becomes much worse beneath the terraces. Researchers found drainage channels carved directly into bedrock. That bedrock is granite. Granite is one of the hardest natural stones used in construction. Scientists measure hardness using a scale called the Mohs scale. This scale ranks materials from 1 to 10 based on how easily they can scratch each other. A higher number means a harder material. Granite usually ranks around 6 or 7 on this scale. Copper, the hardest metal the Inca are believed to have used in large amounts, ranks around 3. This means granite is more than twice as hard as copper. When a softer material tries to cut a harder one, it does not carve it. It wears down instead. The harder surface stays mostly unchanged while the softer tool slowly destroys itself. It is the same reason a soft metal spoon cannot carve a stone. The spoon bends and grinds away while the rock remains solid. Yet at Machu Picchu, granite was not only scratched. It was shaped into smooth, controlled channels. That is why the carved channels are such a shock. These are not rough grooves. They are smooth channels with controlled angles. They are shaped to guide water flow without trapping it. Water moves faster and more safely when channels have steady slopes and clean surfaces. If the channel is uneven, water pools. If water pools, pressure builds. If pressure builds, walls fail. The channels at Machu Picchu avoid these dangers. So if copper could not cut granite efficiently, then what did? No one has found a storage area full of advanced cutting tools. No one has uncovered iron chisels or steel blades at the site. No evidence exists of a tool industry capable of mass-producing something hard enough to carve granite with that smoothness and control. This is what researchers call the tool paradox. The finished work is visible. The tool that should have made it is missing. The known tools do not match the result. If the Inca achieved this level of precision with river stones and soft metals, they were not simply skilled. They were doing something that should have been extremely slow, extremely costly, and extremely hard to repeat hundreds of times without major errors. And yet the errors are missing. The next problem is even bigger. How did they move and place tens of thousands of tons of stone on a steep mountain without modern machines? The logistics that should not have worked. Geological studies showed that much of the granite used in the terraces did not come from the immediate site. The main quarries were located 2 to 4 kilometers away, across the Urubamba River Valley and up steep slopes that reach angles close to 45 degrees. Today, modern hikers use safety cables on these paths. Carrying heavy loads up this terrain is exhausting even with modern equipment. Now consider the weight. Conservative estimates show that the terrace system alone contains roughly 60,000 tons of stone and fill material. That weight equals hundreds of large cargo airplanes or several hundred blue whales. Every piece of that material had to be moved by human muscle. There were no wheels. There were no draft animals capable of heavy hauling at high altitude. There were no metal cranes. Researchers from the University of California calculated what this movement required. Under ideal conditions, with perfect organization, constant labor, and no delays, they estimated that at least 1,500 workers would need to work full-time for 15 years just to move the terrace stone. Those were ideal conditions. Machu Picchu does not offer ideal conditions. The site sits at nearly 8,000 feet above sea level. Many workers would have suffered from altitude sickness. The region receives rain on more than 200 days per year. Mud would have turned paths into traps. The Urubamba River had to be crossed repeatedly. In many sections, it is a violent rapid capable of killing trained swimmers. Spanish chroniclers describe the Inca labor system known as mita. This system forced communities to supply workers for state projects. These workers were not volunteers. They were required by law. Records describe exhaustion, injuries, and death. Punishments were given for failing quotas. Families were separated. Bodies were treated as replaceable. Human suffering powered this construction. But suffering alone does not explain coordination. The 2025 radar studies revealed that many of the largest foundation stones are buried 6 to 8 feet below the current surface. This means the builders did not simply stack stones upward. They first cut deep trenches into the mountainside. They placed the largest stones at precise depths. Then they filled those trenches with layered drainage material and soil. That process requires planning before any stone is moved. You cannot place buried foundations correctly unless you already know where every terrace will sit above them. You cannot align underground drainage unless you already know the final slope shape. You cannot coordinate hundreds of workers across a mountainside without a shared design. Modern construction projects of this scale require survey instruments, measuring chains, reference grids, and written plans. Teams must know where to dig, how deep to dig, and when to stop. At Machu Picchu, there is no evidence of preserved drawings, maps, or engineering manuals. Yet the results show unified coordination across the entire site. Every terrace connects into the same drainage logic, meaning water is guided downward through a continuous planned pathway from the top of the mountain to the lowest levels. The buried foundation stones are not placed only to hold weight. They also protect and align the underground drainage channels so that water never breaks through the walls or weakens the slope. The structure and the drainage system were designed together, not separately. This proves terraces were built as parts of a single hydraulic and structural plan that controlled how the mountain handled both gravity and water. Modern researchers have proposed methods such as wooden rollers, rope systems, lever frames, and large coordinated labor teams to explain how the stones might have been moved. Some experiments show that these methods can move heavy blocks over short distances. However, none of these tests fully explain how tens of thousands of tons were transported across steep river valleys, up 45-degree slopes, and positioned with millimeter precision across an entire mountainside. Even with these theories, the scale, accuracy, and coordination of Machu Picchu's construction remain far beyond what those methods have convincingly demonstrated. If the construction itself already strains credibility, the timeline creates an even deeper problem. The timeline that no longer works. For decades, Machu Picchu was confidently dated to the reign of Pachacuti in the mid-15th century. That date was printed in textbooks, carved into museum plaques, and repeated in every documentary. According to that timeline, the entire terrace system was built within roughly 30 years by the Inca state. That timeline is now collapsing. Carbon dating performed on organic material trapped beneath terrace foundations has returned dates as early as the mid-13th century. These samples were taken from soil layers sealed under construction material, not from loose surface debris. That means the ground was already being worked long before Pachacuti ruled. At first, researchers tried to dismiss these dates as contamination from earlier occupation. That explanation became harder to defend when the next discovery appeared. Ground-penetrating radar in 2025 revealed something buried beneath the visible terraces. Below the current platforms, under 8 to 12 feet of fill, lie older terrace foundations. These buried terraces use the same drainage principles, the same layered construction, and the same stone precision. They are not crude prototypes, they are fully engineered structures. Even more disturbing, these older terraces are not aligned in the same direction as the visible ones. Their orientation follows a different slope logic. That means they belong to a separate construction phase, not a repair project. Someone built a complete terrace system. Then someone else built another one above it. Archaeologists call this a stratified construction sequence. In simple terms, it means the mountain was engineered more than once. This immediately breaks the 30-year construction story. Dr. Joe Cooper from the British Museum reviewed the 2025 findings and stated that either Machu Picchu took far longer to build than previously believed, or the Inca inherited and modified an earlier site. He openly admitted that the traditional timeline no longer fits the physical evidence. The stonework itself supports this problem. The finest precision appears in the deepest foundations. The largest stones show the tightest fitting. The drainage alignment is most consistent in the lower layers. As construction rises upward, the stone fitting becomes slightly less refined. Gaps become wider. Stone faces become less smooth. The work is still skilled, but it is not identical. This pattern repeats across the Andes. At Sacsayhuaman, the massive foundation stones are fitted with extreme precision while the upper walls show rougher work. At Ollantaytambo, the deepest layers display the tightest joints. At Coricancha in Cusco, the temple foundations are far more precise than the colonial structures built on top of them. The pattern is consistent. The oldest layers are the most advanced. Spanish chroniclers noticed this difference as early as the 16th century. By the time the Spanish arrived in the Andes, the Inca Empire was still powerful. Its roads stretched thousands of miles. Its administration controlled millions of people. Its builders could construct suspension bridges, storage complexes, and entire cities. Yet when Spanish chroniclers asked Inca nobles who built the finest stonework in places like Machu Picchu, Cusco, and Sacsayhuaman, the answers were deeply unsettling. Many Inca leaders said they did not know. Some said the stones were already there when their ancestors arrived. Others said the builders belonged to an earlier age. A few described the work as the product of people whose names were no longer remembered. For centuries, historians treated these statements as myth or political exaggeration. Today, those words no longer sound so easy to dismiss. Archaeologists today are more cautious. They no longer insist that Machu Picchu was built in one continuous project. They now speak openly about multiple construction phases, cultural transitions, and possible inheritance. This does not mean the Inca were not skilled. It means they may not have been the first engineers on that mountain. Once the timeline begins to break, the final question becomes unavoidable. Who actually designed the system? The builder's history may have forgotten. After the Spanish conquest, something strange happened. Inca engineering knowledge vanished with shocking speed. Within 2 generations, Andean stone construction lost its precision. Walls became rough, joints widened, complex drainage systems disappeared. There was no gradual decline. There was collapse of knowledge. Dr. Stella Nair, an architectural historian at UCLA, described this as one of the fastest technological regressions ever recorded in human history. She compared it to a modern society forgetting how to make concrete in a single lifetime. This is difficult to explain if the Inca invented the terrace engineering themselves. Knowledge of that scale normally leaves training systems, technical traditions, and preserved methods. None of those survived. Then modern analysis made the problem worse. In the 2025, an artificial intelligence system trained on thousands of high-resolution images analyzed the terrace construction. It searched for tool marks, assembly patterns, joint styles, and structural techniques. The algorithm identified 47 distinct construction methods across the terrace system. 47. Some methods appear nowhere else in the archaeological record. Others match techniques from different Andean cultures separated by centuries and hundreds of miles. A few resemble methods that modern stonemasons say they would struggle to reproduce. Dr. Rebecca Martinez, who led the analysis, said the site looked like a library of engineering knowledge written by multiple authors from different periods, all somehow integrated into a single functioning system. This finding supports a dangerous idea. The terrace system does not look like the invention of one civilization. It looks like the inheritance of many. The drainage design also supports this. Optimization analysis shows that the system behaves like a fully planned solution, not a product of slow trial and error. Trial and error leaves scars. It leaves abandoned channels. It leaves blocked paths. Machu Picchu shows none of that. The system appears complete from its earliest visible layers. This suggests that the knowledge behind it already existed when construction began. The final discovery deepened the mystery. Late in the 2025, deep radar scans revealed a void beneath the lowest terrace level. This space is carved into bedrock. Its shape is too regular to be a natural cave. Its size suggests it was deliberately created. No excavation has been approved. No one knows its purpose. It remains sealed beneath the mountain. Peruvian authorities have stated that disturbing it could risk destabilizing the terrace system above. For now, it remains untouched. Dr. Luis Jaime Castillo, Peru's former Vice Minister of Cultural Heritage, offered a rare public admission. He said that every new technology applied to Machu Picchu shows that researchers understand less than they believed. He said that the more precisely they measure the site, the more uncertain its history becomes. The inheritance hypothesis now stands as the most stable explanation. The Inca did not invent the terrace system. They found it, they respected it, they preserved it, they built around it. They may not have fully understood how it worked, but they understood that it worked. Machu Picchu is not a single achievement. It is a layered memory of forgotten engineers. The terraces still stand, the drainage still works, the earthquakes still fail to destroy them. What remains uncertain is not the engineering. It is the identity of the engineers. Make sure to click the cards on the screen now for more interesting videos.